Hello, this is ABC and welcome to Data Engineering and Infrastructure Community. Our today's topic is
What is data engineering? Software engineering, and but emphasize more on the data. So I always say data engineering for me is software engineering. Why I must say, because when I started, there is no word called data engineering. This is all software engineering, and there was a problem. The problem was we have lots of data, and we all are working on a systems, on a web applications, but honestly everything was compiling and building and running in servers. It can be big servers, small servers, but nothing called distributed in that ecosystem. The cloud was not so popular at the time, it was coming up, and there was no reason of doing parallel computation. Like concurrent computation was very much desired. So people were crazy on learning threads, concurrent programming, deadlock, all those things were like and rise, but nothing on the side of parallel computing. And that's where Hadoop came up. Hadoop, as we all know, it is mostly came up the idea from Yahoo pattern, and they just open sourced it. And what I did it, I just found that problem. We have a problem of scaling or working on a large amount of data. So we just use Hadoop as just a tech stack. It was hard to set up because then first time we realized, okay, we need multiple computer. All of them should have a static IP. They all should talk with each other. And then there is a name node. There's a master. There is worker. All those new concepts were there. And that concept opened this paradigm of distributed computing, which can be done easily by engineers, and that is the entry bar in the data engineering side. Then Spark came, like Kafka came, and many other technology came, started coming, evolving, and they all made up transforming data. Then we found different kind of problem. Databases got very heavy, but in the end nutshell, we are always, I mean, I was always doing software engineering, sometimes in the infrastructure part, sometimes in the programming part, sometimes building pipeline. But in the nutshell, what I was doing, at least still now, is software engineering in a traditional fashion. Focus more on the data. Like I'm playing with data problems. Algorithms are based on data, like structure, divide, conquer, or if there is some other problem of like database is not loading, I'm trying to find it out, how to scale, how to originally scale them, drop it down. If there is a data setting on a large SQL server in a Postgres, for example, 2 terabyte, there was a concept of sharding at the time. Now I'm trying to find out, is there any NoSQL databases with a very high transaction consistency, which follows all asset principle properly. Let's migrate there and try to find out what are the differences. Do I need to change the SQL query? But in the end, I'm trying to understand how it is working behind the scene and then implement. So that's my version of data engineering. That's my understanding of data engineering. And that's why I said for me, it's software engineering. Now I would like to know others' opinion. Like what others think about data engineering?
In my opinion, I say that it's more about cleansing, processing, the proper data. Like it's like making sense for the analysis and
But in your opinion, it is only cleaning, or you can build applications on them? So there are two things, right? We got the data, we clean it. That is one
yes,
thing, and cleaning can be lots and lot of different kind of algorithm. And okay,
yes.
before that, I just need to move back. Considering everyone is fresher, when we say cleaning data, what does it mean?
Like it's like um, yeah, filtering the relevant data, like the relevant data for the purpose, like for what purpose, what we are working, something for like a particular purpose of project, we need to retrieve the relevant data. um, I believe.
Okay. uh, any other opinion on this?
Removing duplicates, replacing null values.
Yeah.
Okay, so why clean data? That like I got a data, why do I need to even clean it?
A proper training of some ML algorithm.
Okay, good, that's a good point.
We need to get the quality data.
for the
to
quality.
take some business decisions or something.
Okay, that is also making sense. Quality data.
So,
You should change the data of the purpose of reports as well as for the predictions of based upon the data which we have cleaned
Okay.
and based upon the reports we can make the predictions.
Okay, that's good. That's a wonderful point. Others?
Making consistent. Let's say you reserved two, three values, same values at a time. Uh, it shouldn't be retrained for those three values, right? It should train for only one value. So in that case, we need to remove those two values. So if there is a proper cleaning happens, so no retraining will happen on the same data.
Okay. Okay, great point. Okay. Any other thoughts on this? Why we clean?
So,
Yeah, Hitesh, go ahead.
yeah. So I would say the cleaning of data is basically related to is it actually a data or is it a noise? Okay. So I'll give an example. Some people might not relate with it, but it is like let's suppose you are just doing a tweet analysis. Okay, and there are some bots which are just doing a retweet, and there are multiple bots which are basically tweeting the same thing. Okay, and what it does is basically, and let's suppose you are doing a sentimental analysis on that. So basically that will skew your data towards that one statement. But if you are looking into the data, you will clean that data out, you will get the actual value of data, what was the actual sentiment analysis of that tweet. So uh, that would be a good example, I would say.
Data by itself has no value until and unless systems doesn't read it and find and do something about it. We use the word clean because most of the time the data uh, is written in a way that systems doesn't understand it. So for them that is a dirty data. It doesn't mean the data is scribble or something. It is just that for that consumer that data is dirty. It doesn't make sense to them. So we transform that data to a particular format so that this systems could read it and derive something out of it. So that is the reason we say we clean and transform data in one of the first principle in data engineering. uh, so after cleaning data, what is the bigger task?
Yeah, their data lake comes into picture, right? Instead of transferring the data from one farm to another farm for different teams, we'll convert like second one, like you have converted into the schema, right? So their data lake will come into picture, right?
What is data lake?
Sorry. Yeah, in a generalized way, in generalized way, I can say that it is a common repository, so anyone can access the data from that point.
Where we can where we can save any kind of data, whether it is structured, semi-structured.
And how will you define a data lake in a layman term?
Able to example like if you go to a wedding, there will be like a table system where you can sit and eat. You know, there are also other system which is called buffet system where you can go and you can pick up whatever you want and you can eat. The same similar thing goes here like that. Data lake is something like a buffet system. Whoever comes in and takes out whatever he wants and then he goes back.
Then the argument will be, if it is whatever I want, then why we need even data engineers? Okay, whatever the data come, just dump in data lake and just tell them, okay, there is file, search and use it.
To transform the data into information.
Yeah, it's like no problem. Yeah, to bring out the meaningful outcome from the raw data. Bringing the data from different source system to respective data lake also data engineer role will come into picture, right? How we are bringing the data from respective position. Like you can say it is a file, or else DBMS, or else DB2 data, whatever it may be. To bring the data also we need to be come across, right? Lot of hurdles, different types of things will be has to be taken care, right?
True, brilliantly said. Other
And
points?
also,
Yeah.
and also while doing all those things, there must be like minimal data loss.
Then I raise a question, Asi. What do you mean by what is data loss? Why we lose data?
Like for example, you think that some data or information might not be useful and you delete it, which others will feel like this is useful, but you think that's not going to make any sense out of the data.
When you talk about what is data lake and where data engineering comes in, so the one of the main thing is if someone says in okay, so whatever data that is coming in, we bring it into a common format and then dump into a data lake. Then what happens with the business users? Because the business users most probably will not be having some scripts or something which can read the data directly, correct? So they need something. So that's where data engineers come in. So then there are data analysts. They also work almost in a similar manner, but they do whatever they do is just most of the time is one time. So what their analysis are sort of like okay, so this is done. So but for that thing to happen systematically, regularly, uh, on time within a given SLA, that's where the data engineering come in.
What are other things data engineers do?
How to use the data. I mean, how business users can use the data from the communication point of view. There's also a lot of room for communication of how the data has to be used, uh, why we need to read the data in a particular format. I mean, if they wanted to run some SQL code or something, which columns they need to use. I mean, I think if you have some tools, that's fine, but otherwise, you have to make them able to understand. So it's all about how the data can be used by the end users, I mean, efficiently.
Absolutely, that's actually a very relevant point. That how to use it. The data availability is not enough. How you need to define other points.
There is one more thing which is called the data around data. So basically, whatever data that you have, so how people are using it and how effectively it is getting it, and what is happening if something is failing or not. So you can call it observability, but it's basically data around data.
That's good. Now you bring a very interesting notion with this. You said observability. It means monitoring, observe. But my question will go to the entire community. Does what just Hitesh just mentioned, do you all agree that it is a data engineer job, or you will say it is infrastructure job, you will say it is a system team's job or DevOps job? What other think about this point when you need to find the loopholes in the data in your pipeline? That is fine, but when it comes to why it failed, what all the systems are happening, why suddenly everything crashed, why data is bad, so and if something failed, you track and debug and try to find the root cause, and then you inform this was the root cause. Whose job it is in every company and group?
Traditionally or normally, you say in a lot of organizations, so there is a separate DevOps team which is basically maintaining your data pipelines. But I think that should not be the case. Uh, I think in in some of the organization or I would say in startups or in startup type environment, this thing has started happening. So basically, so the DevOps of my data pipeline is with the data engineering team, and they are responsible for it. Okay, and that's how it should be, because to understand what is happening, to have a meaning of what is happening, or to generate a meaning from the data, a data engineer should look at the data. Then and only then it will be actual engineering, not oh, okay. I'm not getting the word, but uh, yeah. So you should not be a data developer, you should be a data engineer. So to be an engineer, uh, you need to know the things around it, and then and only then you can optimize certain things. Then it will work in certain manner.
Great point. As I started in the mention point, like I particularly still feel that we are software engineers in the end, and so if you want to think entire end-to-end stack, it is your responsibility to find out any bug, and if there is a bug, fix it, or your group, your team responsibility. Then only you will find the essence and build a solid system where everybody understand everything and it could be fixed fast, because nowadays data teams is centralized team. If something crash and your management or your system is dependent on data every day in the morning to do a right prediction or a model, uh, if it just crashed and you don't react fast, it means you just brought down the entire company revenue. And that's why this is so important that either the team of infrastructure sits very closely to engineering or sync up, or as a data engineer you understand what is happening and you fix it. Then what is data warehouse? Difference between data lake and data warehouse. Yeah.
Yeah, I see data warehouse to be the central, uh, collection of, whether it is dumping zone or whether it is something where cross-functional teams operate centrally through, looking for master data sets, looking for way we are defining, the organizations define their KPIs, etc. That's central for data warehouse. Whereas data lake, on the other hand, seems to be the experimental zone, the the where the place where you want to sort of do the mechanics on your models. Do you want to do you want to play around and see what what does your experiment look like? So that's the it's the kind of perception that I've come across working in, at least working with clients in small consultancies. Yeah.
Any other thoughts, opinion?
I think traditionally data warehouse. I think we are hearing that data warehouse award from starting of the IT onwards. I mean, mostly in the sense, majorly they're dealing with the structured data kind of thing only, right? In data warehouse.
Okay, I mean, as you say, like every company works in a so different way, so that what you're
Yeah.
saying is right actually. Some consider data warehouse is just about structured data or
Yeah.
queryable data. Yeah, that is as well one of the points. Any other
When
opinion?
it comes,
Yeah, yeah.
yeah, when it comes to data lake, it is like altogether any kind of data, whether it's a structured or semi-structured or else unstructured. We are bringing the whole data all together into the one place, right?
I guess by the definition it goes very similar to how storages work in all these leading clouds, right? If you go for AWS, you go for something that leads to Glacier, and you eventually look at Glacier figuring out its way into the lake. It's a little philosophical over there, but warehouse, on the other hand, it's by definition of the name. Going by that is something where uh, things are made. And it depends on what kind of organization you are, right? If you're looking at enterprise data warehouse versus application data warehouse or product data warehouse, then by definition it eventually ends up being that. And data lake, on the other hand, becomes something where you want to have uh, more relevant to storage, and more relevant to the way that we are accessing the data. uh, it's how we are accessing the data and utilizing it.
Okay,
Great point.
I have a sort of a different approach to it. So I would call let's consider I'm just drawing an analogy. Okay, since most of the people are new to the data engineering. Market for fruits. Okay, let's suppose it's a fruit market or a vegetable market. It's a big vegetable market. Okay, and data warehouse is basically from whatever the fruits are normally before coming to your home or to your local vendors. What happens? The fruits are sorted out in a different quality, different sizes, and normally they are packed into some sort of boxes, and then they are bought by the vendors, vegetable vendors or whatever local vendors, and that's how you use it. So basically, your data warehouse is basically it stores that sorted out data, uh, and your data lake is a data which basically contains your raw data or thing, and then from the warehouse, basically your local vendors, you can go and buy the fruits, or basically use the data, or the final users most probably use the data. But now, since we are talking about the data lake and data warehouse, so there is one more term called the data warehouse. Sorry, data lake house. Data lake house. Okay. Yeah. It is sort of a mixture of both. I'll not go deep into that, but it's a mixture of both. So it's sort of like, you can say it's a Walmart.
Idea what is operational data store?
I would not uh, categorize as a separate thing as an operational data store, because it's another way of storing your data. Okay, so it's basically your time series data for sensors or something else. So it is just another form of data that is being stored. I do not categorize it as a separate thing. That's what I would go about. But some people who are basically in doing that stuff around the data, and there are a lot of intricacies that revolves around handling the operational data. That's where you hear the separate term as a uh, operational data store.
And data mart, I mean, since we are already in this flow, the question came up, what is data mart then?
I guess it's just much more refined, client facing kind of thing where you have everything relevant to a presentable layer of access instead of the data warehouse and data ODS and data lake. You have a much more refined version of things where because these are specific, like you see that only analytics teams, a specific analytics teams uses a data mart for marketing analytics versus for domain specific data, which is sort of curated, filtered, and structured in a way that can be consumed by uh, with a lesser overlay by BI or by analytics teams, would be something that the data mart would be much more appropriate.
Okay, great. So yeah, in my version of story, then I will say, I always say this is just an analogy. It is where we say data is raw, then just call it as silver, and then you go for gold, and then for data mart it is a diamond for me, or platinum for me, where you just transform and make it for a very specific use case, which is extremely clean. Which, by the way, nowadays I give that responsibility to the team. I said, okay, I'm not going to build that consumer team will create their own mart and do whatever they want. What are the other things?
So a lot of teams have an overlapping set of responsibilities when it comes to ML ops, data ops, and data engineering, where you have hardcore ETL versus data warehousing versus just productionizing your data versus uh, trying to figure out there are some optimizations that you do on top of what data science team actually did in order to scale it to an extent. So there is that angle as well, where we bring in our expertise in PySpark or Python, or which is much more optimal than what data scientists do in increasing accuracy of the model, kind of storage, kind of data structures that they're using. We try to optimize that, as well as maybe at certain point also increase sustainability of the model performance. Maybe they might not have seen this in their BI, but after our productionalization, we would be able to see a lot more clearer, a lot more consistent result. So yeah, that's the MLOps angle, I guess.
No, it's absolutely good point, because uh, some data engineers work very closely with data science, and it is more or less doing everything. You sometimes even review data sciences code and productionize it, adding ML ops infrastructure. So as I say, some team has quite a lot of or with a significant data infrastructure involvement as a data engineer. So it is going more and more closely to the software engineering side, where you know it all, like some says full stack data engineer, but there's nothing. It is one of the other responsibilities. Okay, so we got from data cleaning, ETL, data warehouse, infrastructure, any other things which we are missing as a data engineer we do.
Work with data analysts to improve your queries, not just the data scientists, but with data analysts. So a lot of time you're pulled in. Okay, so this query is taking quite a lot of time. Let's suppose this query is taking 15 minutes to complete. Why is it taking 15 minutes to complete? How can we change this query to have the result in lower amount of time, and generating the same result?
So optimization and helping other groups, like whoever your consumer, go to them and try to solve their actual problem as well. That is another point. Okay, I have one to add. I don't know how many of you faces it, but I have faced many things explaining it. Not only in the data science view, but explaining the data, or you must say, I just given a lot of data, and as an analyst and a data scientist, you just don't know, and you make it avail, like somehow you read it, but then you talk through it, try to explain why I'm building this, what is the main improvement we can do by changing the schema, for example, from JSON to protocol buffer. So like talking and speaking through it, like going and reaching different community and team inside the group, and try to understand the harmonization in the tech stack. So that, because data engineering is so overly complicated because of so many technologies, it is always good that if your entire company has a similar kind of stack, so that the problem happens, you have an answer in a one Slack, because somebody would have already faced that problem, or you find a very good solution, you posted it. So that is another area where I invest quite a lot of time to find a harmonization around the tech stack using inside the same company, and catching up with the technologies. So as a data engineer, if I'm involved in infrastructure and deployment, it is always a kind, okay, I am doing querying and pipeline, I heard this DBT is a very good system, give me that. Machine learning, PySpark is good, but I want Ray, or I want PyTorch, give me that. Now whatever the infrastructure you build, the scaling doesn't work in the same pattern, maybe or maybe not. So that is one of the work I am involved in, but I won't say everybody is doing it. But is there any thought on that? Do you say that is the work of data engineer, or you would say, argue, no, that is not?
Well, I completely align with that. Like we see, we sort of serve a lot of teams, a lot of dashboards, a lot of insights, a lot of decisions, and eventually when they try to match, so we sort of also bring in the communication between the data science and BI layer, the data science and the tech layer, data science and a lot like and even the if you like say for instance for pharma itself, right? You have so many data sources coming from so many different places, and say you want to look at the patient journey itself. You see, there are so many touch points, and it's only the data engineer who would be the go-to person in the organization who would know that this is what you should look at, looking at data lineage, data catalogs, and everything. So yeah, that's absolutely something that and the organization loses a lot of this focus because their focus is to get their product profitable, or making those decisions that are going to impact the dollar, but in the process they don't actually say forget to document their own efforts in the past, their own models in the past, and at the end of the day they are lost again. So it's the role of the data engineer, which is critical at this stage, knowing the entire blueprint of data as such.
Data literacy or entire ecosystem literacy is now becoming one of the data engineering job. So as if you are already entering into this field or want to enter, just realize that the dimension of data engineering is so wide that whatever the current skill set you already have, maybe you already overlap with data engineering. So if you're already working in SRE DevOps, maybe you just need to know some of the data specific tools, but you're already can be a part of data engineering. If you are in data science and you do deep analysis on the model, but you want to understand before that how to deploy that model. So maybe as a data scientist, you can change the track, go bit up in the upstream and downstream, and then you start working as a machine learning engineer or data engineer. So the beauty of, that's why I like this particular role. The beauty is it has so many overlaps that you just need to put some effort to just move from doing something like ETL, then you say, no, I want to do operation. No, I just want to build pipeline. So I want to do engineering, heavy engineering, like running things on the streaming and doing real time dashboarding. So those are complicated. So that's the main essence when I say data engineering is pretty wide and it is complicated. It is complex. It gets very complicated when I would say the size of data grows and more product lineup comes.